Alright everyone, let's look at lesson 1.9 from calculus, and we're going to do it quick. So what 1.9 is all about is multiple representations of limits, looking at limits algebraically, through a table, and through graphs. We're not going to do any of that. What I really want to look at is the one-sided limits done algebraically. So what I have for you is I have two problems that can only be done with one-sided limits. The first one is very apparent that you're doing a one-sided limit, and the second one is just a little strange, and we'll talk about that soon. So let's start with the first one here. If I plug in direct substitute 3, I get 0 over 0, indeterminate. So gives me the feeling that something could have been done. We could do some sort of simplification, but for our intents and purposes, we really don't need to because we're doing a one-sided limit. So this is done to estimate what's going on here. So if I'm looking at the right-hand side of 3, I'm going to use 3.001 as a really close approximator for this. If I directly substitute in 3.001, I'll get 3.001 minus 3 in an absolute value, and then 3.001 minus 3 outside of 1. Well, we can clean this up a little bit. 3.001 minus 3 is 0.001. That would be an absolute value. And then we'd get the same thing outside. The absolute value, all that does is evaluate the distance from 0. In this case, a positive number's distance is still positive. So we get 0.001 over 0.001, which is 1. So this limit, on the right-hand side at least, approaches 1. What if we have something a little weird like this? Well, if I plug in 1, I get 1 over 0 squared. That's not indeterminate. And since it's not indeterminate, there's not much we can really do with it to manipulate it to be something useful. But what I can do is I can do something similar to this. Let's look at the limit as x approaches 1 from the right, and the limit as x approaches 1 from the left, and let's see what happens. So if I go 1 from the right, I'm going to use 1.001, and from the left, I'm going to use 0.999, and I just want to see what happens. So if I plug in the 1.001, I get 1.001 over 1.001 minus 1 is 0.001 squared. Now, I don't really know what this is, but I can make an assumption. And how I can make that assumption is I'm taking a number, 1.001, its size, it's all right. But the 0.001 on the bottom is a very small number, and I'm squaring it, so it's getting even smaller. So I'm dividing a number by a really, really small number. This is going to be huge, and the closer we get to 1, we'll find that that number gets bigger and bigger and bigger and bigger. So the right-hand limit is infinity. Let's look at the left-hand limit. I would have 0.999 over 0.999 minus 1 would be negative 0.001 squared. Now we can also rationalize about this one. 0.999, it's a number. I wouldn't say it's big, I wouldn't say it's small, but 0.0 0, 1 is pretty small, and we're squaring it. Now think about what happens with numbers. We're taking a negative number and we're squaring it. It's going to become positive. So we have a number over a positive but really, really small number. What's going to happen? The same thing that happened over here. That's going to get closer and closer to infinity. The closer and closer our number is to 1. So since both sides are approaching infinity, this limit is infinity, because that's how limits are defined. What happens on the left, what happens on the right, what is it getting close to? And in this case, both sides are getting closer to infinity. And that is all I've got for you. So I wish you the best of luck with your practice with 1.9. Again, if you need anything, ask questions. Other than that, I'll see you in the next video.